How's the pronunciation for that?
Studa
pitch means, let's say, shut down and restart in Napolitan, so you can use it then.
Apparently always works.
Yeah, exactly.
So, thank you, Lorenzo, for inviting me, and hello, everybody. My name is Luca Pradovera, and Lorenzo gave me a good introduction, but I'll give you a little bit more information about myself, what I've been doing, and what I will be doing in the future. So, I have about 20 years of experience in RTC, because I started working with Flash, and the interesting things you could do with Flash and RTMP back in the day, and honestly, I think some of those ideas were still good, and I see that we're finally picking up on those, but more on that later. Then I went through ZIP, WebRTC, by way of XMPP, which is the protocol Adhesion is based on. We started building true complicated voice applications in Mojolingo back about 10 years ago when it was still pretty novel. So the idea of using a true programming language to run an IVR through the Adhesion Ruby framework, which I am a core contributor of. The project is slowed down because we basically consider it complete, but it's very much alive and people use it in production. We use it at SignalWire too, and we build applications for many customers. I joined the SignalWire team with the idea of finally disrupting some of the various core tenets of telephony that were going on around the industry. That's what we're going to try to do. But first of all, what is this presentation about? I added this slide because David said I needed one, so this should be one of the first things. So, first of all, how many here actually use FreeSWITCH? And what if we add people that have FreeSWITCH in their organization but don't actually deal with it? Is there more people?
More or less the same, yeah. So not many, so it's great that I can introduce this a little. It's a term that you've heard thrown around these days, so it's interesting to see what FreeSWITCH actually is. How can you pair FreeSWITCH with Janus? We'll see that FreeSWITCH pairs extremely well with Janus because it has a complementary set of features that really complements the system almost perfectly. Then we'll touch on what SignalWire actually is, mostly because people think, well, now that there's a company running FreeSWITCH, it means FreeSWITCH is not going to be open source anymore, things like that. All of that is wrong, so I just want to look into it. And finally, tying it all together with the various interoperation ways we've used with Janus so far, and we will be doing in the future. We have a couple of production projects and some others that are in the making that use Janus as the main component or as a extra component to provide more features. So, FreeSWITCH. FreeSWITCH recently got the 1.10 release, and again, SignalWire got started, and much more happened. But first of all, let's go back to the FreeSWITCH platform proper. What is FreeSWITCH? FreeSWITCH was founded in 2008 by Anthony Minisali and quickly joined by a couple other core developers. And it was built on the idea of innovating an area where really there only was Asterisk at the time. It was briefly alive as an Asterisk clone / fork of sorts, then it started being rewritten from the ground. So it's free and open source, and it provides many ways you can build applications around real-time communications, voice, video, even chat, and WebRTC, I wouldn't say recently, it's been a few years, but still, it's more recent. It's built around a very solid core that's very well performant for what it has to do, and it's very modular, so you can only load what you actually need for the application. We got WebRTC in the core, we have conferences, a way to serve XML DL plans via HTTP, so you can serve your entire fleet of servers using only one web server that has the HTML on it, the XML on it, and just return the necessary XML for each call. And many more other modules, including, for example, support for libAV, which means FreeSWITCH can speak basically any reasonably used video format, and many non-reasonable used too, like there's some weird stuff in there. It can be used as a PBX, as a switch, as an SBC, media server, application server, WebRTC server, many other things. So, state of the project. We released 1.10 in August, and it's got many interesting features. Amongst them is the Raspberry Pi support, Debian buffer packages, the new unit test framework that guarantees a certain level of performance. A unit test framework actually tests for performance too. A MariaDB module for people that use database support, the ability to run JavaScript as a script in the background, so you can script your applications in JavaScript directly, and a lot of features. There's a link there. What's important to say is that SignalWire is the official sponsor of the FreeSWITCH project that will remain free and open source. So everything else you've heard is wrong, period. FreeSWITCH is moving to GitHub, so we finally decided to move off from Stash. For the few of you that have looked at the source or contributed to it, it was a pain, I know. The idea is to re-engage, re-energize the community. We had to do a lot of work on tooling. It's not a painless move because, of course, everything revolves around your Git repo, right? So builds and CI and all the stuff. And it was made possible by SignalWire, but contributors are still welcome. So anybody that wants to help out, this is the right moment because moving to GitHub means it's much easier for everybody involved. So FreeSWITCH and WebRTC. This is where it gets more interesting for what we're talking about today. So FreeSWITCH has a completely different video model than Janus. While Janus uses an SFU model, so every video feed is sent separately in its own stream, FreeSWITCH will mix the video in a single resulting stream and then send that back to all clients. You can define that in a variety of ways. I won't go through all the configuration options because there's literally hundreds. But the main point is that this approach uses less resources on the clients because they only have to contend with one video, but more resources on the server. That's absolutely true. Like Janus can pass, we saw earlier in other presentations that people were running 500, 600 streams through a single Janus node, and they were complaining. I'm happy if I can run 40 or 50 on a single FreeSWITCH server, but that's because it's completely different, right? We're talking normal size machines, right? If you have 120 cores, I want to try that machine, but other than that, I don't know. Signaling is driven by Verto, which is a JSON-based protocol that's just over WebSocket. As you know, signaling in WebRTC is almost non-relevant. Like everybody has their own idea of how to do signaling. They're all flavors of JSON RPC style packets, nothing more. So this is an example of how video mode can be configured. You're not limited to a grid. You can have a large video in one corner and some others around it. This could be a simple grid. This could be split in four. So you're not limited to that. And you can dynamically change the layout in the conference, which makes it not as rigid, makes it more flexible than it looks essentially. So how do we combine the two platforms and how are they relevant and so good to be used together? Because I'm saying success because we have a couple successful projects in place that have both working together in various capacities. So Janus provides an SFU and FreeSWITCH provides video mixing, but also the SIP interop, general RTC capabilities, a little bit more of transcoding capabilities, so the ability to translate videos from one format to another. There's a bunch of things you can do with FreeSWITCH that are easier in FreeSWITCH, but Janus has an unparalleled capacity for SFU streams and also as a great REST API and all the various APIs, but we're using the REST API that allows you to do pretty much what you want. So they're very complementary. Both platforms speak WebRTC, and Janus also has a SIP plugin, which we used for a while, but was switched off because we needed to do more tight integration. And we ended up building something similar to what Giacomo presented yesterday, with uses signaling, which is also always JSON. So our use case was this. Customer required the ability to have SFU video on the screen when you were on a desktop, so you can move single people around, have them make one of them larger on your screen. This is client side. Like people want to see this guy bigger, they will just move it. And but they require MCU mode on mobile because otherwise it's really difficult to handle a room with 14 or 15 people on mobile with single stream. So we do one video there. SIP bridging was needed. It's still not complete. We'll see later because of legacy conference room equipment. So for them now, we're using a different approach, but we'll get there eventually. And recording the MCU with the audio gives us a ready-to-go rebroadcast format. These guys do rebroadcasts of the events they do, which are a hybrid of webinar and roundtables. So people that participate actually speak. They don't just look. They participate into the conversation, and this is all about law and specifically the U.S. law and government law. So they're all important lawyers that talk about the topic, and then those videos are actually sold. Like they take the video. This gives us a completely ready to rebroadcast video that's already formatted. It's got video mixed in the correct format, etc. It's just great. How did we solve it? A B2B UA-like agent, so it's essentially something that speaks Janus on one side, Janus WebRTC on one side, and FreeSWITCH WebRTC on the other side, and just puts it together. So this is, in a pinch, this is the layout, which is more or less the same idea that Giacomo was speaking about yesterday, only it's built differently, and we'll see why. But this is, so aside from the Rails app, well, not aside, so much of the logic of this platform is in the Rails app, because both of the media platforms are being moved around by REST commands. I like keeping my media servers as dumb as possible in a complex architecture. So I like all the logic to reside in the web app, and the media servers can be scaled out, swapped out. One of them dies, just roll another in. They don't have to have any state. That's my personal preference in architecturing a solution like this, but it's generally useful. So the implementation, it's like Giacomo's, but it's Python. I'm done. Thank you very much. Well, no, actually not. So I found out, talking with Giacomo, I found out that we have a different approach, actually. So aside from it being written in Python, where we connect to FreeSWITCH using the Virtual protocol, which again is just JSON over WebSockets, and to Janus using the Video Room protocol, which is again JSON over WebSocket. In our case, all the clients are joining the Janus room. Nobody is actually joining the FreeSWITCH room as a publisher. Everybody is on Janus. We just use FreeSWITCH to relay media. The back-to-back UA takes care of DTLS, RTP, etc. And the FreeSWITCH conference is essentially an empty conference which does have the MCU mixed mode video and audio. This is a better diagram. So what happens is that mobile users actually get audio, have the video and audio stream going to Janus, and they get audio back to Janus, but then they also call into FreeSWITCH. So every mobile client has two calls up. One is to actually participate into the room they need to talk into, and the other is just the mixed video, so that we don't show the video coming back from Janus. We don't subscribe to the Janus stream. We just show the FreeSWITCH stream. And desktop users have nothing to do with FreeSWITCH. Desktop users are just on Janus. They don't care. There's never been a reason why desktop users will have to tap into FreeSWITCH, but it will be easy to do. Just add a new media stream on the browser. It's just not needed at the moment. So what do we do? So what's the challenges really? Managing participants is easy in the current model where FreeSWITCH is and the B2B UA are connected to Janus as a subscriber only. They just get video streams. Publishing is a different can of worms, and it's something we haven't gotten into yet. Still requires a lot of external state and orchestration. Most of that will probably not be, I can probably take all of the complexity out, but I would like to be a little bit simpler. I would like to use more, so what we're doing now is everything is active. Commands come from the web app and do things like call this guy, connect this other stream. I would like for the architecture to be more reactive. Since both platforms provide a very good event stream, you can actually react to things instead of having to do them yourselves. Well, solving complex situations is a hassle. It's something that everybody has in any platform, so that's really just our problem. But honestly, the most interesting thing I discovered working on this project was how Python proved to be a great platform for building this kind of application. Everybody thinks about JavaScript as the first go-to when you're building. Everybody knows, there's more people that know Node than they know Python. And I'm not a Python expert. I just like prototyping with Python, and I found that the async IO framework and the related libraries that work with networking in Python are really, really good. So take a look. That's just an aside. It's been very useful. So where are we go now? We have two projects in production, but we won't stop there. SignalWire changed things a little because what we'd like to do is provide some kind of I wouldn't say official, but some kind of connector for Janus to work with SignalWire, which is just hosted FreeSWITCH essentially. Again, we have no SIP access because the back-to-back user agent from FreeSWITCH is currently just subscribing to video from Janus, so it has no way into Janus. It's relatively easy to do. We'll probably be working that in the next month or so, but right now we don't have that. And that's so the old architecture we're using was all SIP based, so we had this, but it had other problems. This works, the other didn't, so that's important. As a result, again, this is much simpler and actually works, which is the first thing you want to do in your projects, right? They have to actually work. So when you undertake, so I'm trying to work through this like it's a case study of sorts. When you undertake such a complex project, first of all, you have to make sure you're working in the minimum possible unit that works. Like just build it small, then add things. Don't talk to your sales and technical sales people like myself when you're working on this. Just do it as engineering and then scale it out. Otherwise, it gets a mess because everybody wants H323 support. Somebody else wants support for a video format only their grandmother know and use, and it gets complicated pretty quickly. So, but we're going to add to build the second iteration of this project on SignalWire. So just briefly, because I don't want to turn this into a advertising presentation because that's not the goal. What's SignalWire? SignalWire is a cloud-based provider doing voice messaging and video, programmable communications, the usual thing. We like to say that we are based on FreeSWITCH because it was founded by the founders of FreeSWITCH, and we like to say that we have a very good pricing because we think many companies in the space are overcharging for technology they didn't even invent. Well, at least we invented this. It's just interesting. But still, it's a good way. So what we want to do is we wanted to build something that will appeal to developers. So our first goal in designing SignalWire was to have many different ways of interacting with your voice calls, video rooms, and whatever. And the two main control APIs we have right now are Relay, which is yet another JSON-based WebSocket channel. We've seen two right now. This is the third one, so we have plenty of those. Gives you real-time control with minimal latency, so essentially you get all the benefits of running your own FreeSWITCH locally, but it's in the cloud, and you don't have to care about many things that get complicated. There's an event stream. You can react to people, for example, joining a call, being a hang up, done recording. All of the stuff gets piped through the JSON. Otherwise, you can use LAML, which is the legacy antiquated markup language. I didn't come up with the name, but I like it. Some of you might remember there's another cloud provider which name ends with IO, that most of their initial fortune, and I give them credit for that, was based on this XML-based webhook interface. So you get a call, an HTTP endpoint gets reached out, and the HTTP endpoint gives the server the XML with whatever the call is supposed to do. This is the comparison. Relay is just Relay JSON and is more real-time. LAML is more declarative, and it's built around the idea of simple IVRs and simple iterations. Relay is based on a persistent connection, so you can just stay connected and have things proceed as you go. So what can we do with Janus and SignalWire? We have SIP connectivity. It's very, very easy to get a PSTN number and get it hooked up with a SIP plugin in Janus. It takes probably 10 minutes. We have one-on-one calls on WebRTC and WebRTC conferences with the MCU. Again, this is still relevant. You can more or less, we will be able to do more or less the same thing with SignalWire. What's useful, SignalWire has the ability to tap any stream, any video or audio stream you're having in your call or conference and send it to a separate RTP endpoint. That's going to probably be one of the features we use for full Janus integration, because if we want to get the MCU video into Janus, it's easier to pipe an RTP stream than have an entire peer setup, a publisher, etc. I would just spit out the RTP to something and just have it get into the room. Also, there's the recording and playback and events, all things you can tie around while keeping the core in Janus, that is the extremely performant and easy to configure and use SFU that allows you to run a lot of channels on a single machine, which is very important. So right now, what do I have working? Right now, I have this demo, which I won't bore you with because it's really just literally a phone call, that goes from the SIP gateway through WebRTC to SIP to WebRTC again. So essentially getting a call from browser to browser, but through SignalWire. That's slightly more complicated than it looks like, because of course we need to, there's the back-to-back user agents is involved again, and there's a bunch of prototypes we're building. But the goal is having so the project I described earlier, the goal is having that released soon as a Python repository you can play around and bring your your SFU conference on Janus into an MCU conference in FreeSWITCH or SignalWire, because honestly they're sort of like the same thing. I'm not sure how SIP access will be managed yet, but I'm working on that. We still have to start on that. Good. So again, we're gonna release the Python connector. There's so many publisher connector ideas we have, from playback to doing streaming. We already have in place a large HLS streaming infrastructure we can use to leverage the Janus streaming to scale out quickly. And the idea is that I would like to keep Janus as a first-class friend of SignalWire and always be able to interoperate in a few ways, even just with code examples and whatnot. Who knows? Maybe a RIP is coming. Maybe a RIP isn't coming. It's going to be a long way, but still, it's not something. It's not something for today or probably next year. I'm not even sure. Good. So really, that was it. Thank you very much. I look forward to helping with any of you with questions regarding especially FreeSWITCH and the open source side of things. But also, if you have any other questions, I'll be happy to help. Thank you very much.
Thank you, Luca, and very interesting presentation as well. Do we have any question for Luca? The guy was there first.
Hi. As I understood correctly from one of your slides, you receive audio from Janus and video from FreeSWITCH. How do you keep in sync, the audio and the video?
We don't generally care. Those are two separate WebRTC calls. One has the audio on it, one has the video on it. Since it is a conference, it doesn't matter too much. It's not a sporting event or something like that. We never had particular reports of things being very much in sync. So there's no active way in place of keeping them in sync. It's just usually been good enough so far. So it's just that. It's the short answer is we don't, but it's never been a problem.
Okay, thanks.
Hey there. A couple of slides ago, I think you had this. What other things can we leverage from Janus, I believe? Yeah, so SIP connectivity, PSTN numbers, and one-to-one calls. Why would you put those in Janus instead of keeping them in FreeSWITCH?
Mostly performance. So if you're talking about FreeSWITCH specifically and not SignalWire, which is a different platform, but if you're running things in open source, if you're running a huge number of one-to-one calls and you really, really want to be on an SFU, like just for scaling, from a scaling perspective, because SFUs are infinitely more scalable.
Okay. And sort of second part to this, you said that you have this demo that you go from SIP to WebRTC, back to SIP, back to WebRTC. So have you considered, or what are your thoughts on if Alice calls Bob and they are both using SIP, because it feels like it's a boring call, but you do know in your platform that they are both reachable via WebRTC. Would you upgrade the path to be simpler without less components in between, just a WebRTC call between them?
Yes, we actually do that on the SignalWire side of things. So if you register as both SIP and WebRTC, we're called the WebRTC endpoint. But that's something that's probably better left to the application logic themselves. So doing upgrading the path, you mean keeping out of the media path? It's something that it's not always desirable, because generally speaking, the platforms I built and we built over the years always needed some kind of either recording or playback capabilities. So both of them needed some degree of control on the media path.
Got it. Thanks a lot.
This relay protocols that you mentioned, is it part of free offering of FreeSWITCH, or it's extra, which is part of SignalWire?
Relay is the control protocol SignalWire uses. On FreeSWITCH, you can use ESL, which is the event socket, which is more or less, so what relay is a mapping of a subset of features to JSON, really, to make it usable from WebSockets. But you can certainly use, on FreeSWITCH, you can use ESL, which probably does even more things. So if you're doing FreeSWITCH yourself, you don't need relay strictly.
ESL is just events, right? To invoke request, I need to use REST, right?
No, ESL is everything. Like it's event socket. It will do everything you need. There's libraries for any language under the sun, and yeah, I will recommend using ESL if you're in FreeSWITCH. Relay is SignalWire only, but Relay itself, aside from being a gateway to how we handle scalability and the fact that we have hundreds of servers and you have to care about that, all the kind of thing, it doesn't do anything special. Like you can make calls, play EDO, whatever. It's not very much different from what you can do on ESL.
And one more question about this lightweight JSON protocol for WebRTC. It's Verto.
Yeah.
Yeah. Does it support full like offer answer model? Like I can send also modify media session, or it's just setup and offer answer initial call setup, and that's it.
You cannot modify the media session, but that's there's some ways around it, because actually you can. So call setup on Verto is really fast. It's kind of like a setup you have on a call in Janus. It takes split seconds. So generally, what we advise is just pull the call back up. It's easier to manage.
Any more questions for Luca? Then thank you, Luca. Thanks.
Thank you.
And now it's time for lunch. So we can